Okay, one more little thing before you write your first unit test this week. And never panic. You guys have been doing a really good job on these linear relation questions. Let's assume we have another question and I'm asking you to solve it graphically, all right? Or with a table of values. So let's say Mark bought $12 donuts and 1 muffin for $14. And Lisa bought 4 donuts and 2 muffins for $8. And I asked you to solve it graphically. So I know that some of you right away you're excited because you've learned how to do elimination or substitution and you're like, let me just jump right into the numbers. But I'm like, the question says to come up with, on your create your own quiz, it says to come up with a question graphically. Okay, so remember, the first thing, even if you don't have graph paper at home, don't stress about it, right? But the first thing you're going to do is you're going to make yourself your axes, and you're going to get points even just for labeling your axes. Even if you just do this and you just say an X and a Y, remember Y to the sky, Y is up and down. You even get a point just for doing that. So even if you can't answer the question, but you can at least label your axes, you would still get a point for that. So now we have to think, all right, we had a whole video on how can I make equations, right, based on word problems like this. So we say to ourselves, well, we have to do our let statements, right? So I'm going to say let X equals the cost of a muffin, and I'll let Y be the cost of a, oh, actually, sorry, because they talk about donuts first. I meant to say donuts. This is why we use pencil. Okay, because they talk about donuts first, so just keep it easy. Donut and muffin. And again, you get points just for doing that. So even if you're like, I don't know how to write these equations, just always don't panic. What do you know? What do you know? Well, about 12 donuts and 1 muffin for 14. Now the financial questions are, it's nice to solve them this way because they're going to work. So, okay, I'm going to say 12x, about 12 donuts and 1 muffin for 14. There we go. There is your equation. Second line, Lisa bought 4 donuts and 2 muffins for 8. Now, in your mind, always look to see if these are actually just a factor of each other. They're not, right? So the difference or the factor between the 12 and the 4 is not the same as between 1 and the 2, right? This is doubled. The 1 would be doubled to make a 2. Well, that's not the same. That's not the same. Because right away, sometimes you can just look at the equations and you can tell if they're basically the same line because it's just a version of each other, right? If they're the same factors. So let's have a look and think, all right, I have to graph this. She says I have to do a question graphically. Well, graphically, we need to put it in slope-intercept format. Okay, so step 1, well, I guess this is actually step 1 was writing our, this was actually step 1 was writing our let statements. This was kind of step 2 was writing our equations. This, let's call it step 3, put it in y equals mx plus b. That is our format that we need, right? Because then I can plot it because I have my y-intercept and I have my slope. Well, again, this is going back to grade 9. You guys should remember this. If I take my 12x plus y, and I know I can kind of just drop the 1 in math, and I have to write it like this, well, the y doesn't change. The y is still on the left of the equals. But this 12x went on the other side. So I know I have to go minus 12x. And the 14 didn't change, right? Plus 14. All right, now I'm going to need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, I didn't leave myself tons of room. So I'm going to call these up by factors of 2. So this will be 2, this will be 4, 6, 8, 10, 12, 14, 16. So I know that my first y-intercept, right? Here's my first y-intercept. I'll do it in a different color. I know it. I can see it. Here's my y-intercept right there. It's going to be right there. And my slope, right, down, it's negative 12. So rise over run. So I'm like, I have to go over 1 now. Let's do the same format. Let's call this one 2, 4, 6, 8. So 1 would be about halfway, right, between. So I have to go over 1 and down 12. Well, if I'm at 14 and I have to go down 12, I'm going to end up on 2. So I'm kind of like 1, 2 is going to be that first, do it in pink. There we go. So there's my 2 points that are going to be on my first line. Now, again, can I graph 2 points? Yeah, I didn't leave a very good, I could have made maybe a different scale here, but it does work, right? So here's my first line. Always put your arrows on it and then label it, right? Again, you're gonna get points just for labeling it. So this is y equals negative 12x plus 14. So that's my first line. I'm solving this graphically. That's what I'm refreshing you on. Then I have to do my second line. So I have my first equation up here. Now I have my second equation right here. So I've got to turn 4x plus 2y equals 8 into y equals mx plus b. Well, leave the y alone. It's already on this side. Move your 4x over. Plus 8. Well, I can't have 2y. That's not part of the y equals mx plus b. Well, luckily for me, they're all factors of 2. So I can just take 2 out of all of them. Y equals negative 2x plus 4. Okie dokie. Well, I'm going to get a different color here just so you can see what I'm doing. Right, here's my second y-intercept because that's the format that it's in. All right, so where are we? 4, right here. All right, so I have to go again on my slope intercept format. I'm going to be going over 1, down 2. Okay, so if I go over 1, I'm at 4, and I go down. Oh, it's right on top. Yeah, that's the point. I mean, at some point, they're going to be on top of each other, and it just happens that that's going to be our intersection point right there. But then you're kind of going, yeah, I mean, I could. I guess it's only 2 points. It could kind of sort of look like that, but it'd be kind of nice, wouldn't it, to have some extra points on this table, wouldn't it? Well, no problem, right? Because you can do a quick table of values, and sometimes you're given the equations and you have to figure out your own table of values. Well, let's say to ourselves, normally with our table of values, right, you have your x and your y, and you decide, but there's a lot going on down here, isn't there? So it doesn't always have to be -2, -1, 0, 1, 2. I mean, you can take a bigger number, so that's allowed. So again, a lot of times we ask ourselves, well, maybe I just want to be able to get a point over here somewhere, a point over here, just so I can, have a little more confidence of where to put my ruler. So I'm just going to try to go a little bit bigger. Instead of just doing -2, I don't know, maybe I'll try -3. So if I put a -3 and I'm subbing it into my formula here, so my formula is y equals -2x plus 4. And now I'm going to sub in a -3. Oh, okay. So now -2 times -3 is a +6. Plus 4 is a 10. Oh, okay. So at -3, my y should be 10. Okay, so that's going to be easier. So here's my -1, -2, -3, and I'm going to go up to 10. So that line, yeah, that's gonna help me a little bit more. All right, what if I just throw a 0 in there just to kind of see? So it's going to be 0 and 4, which we know, right? Because that's our y-intercept point. So maybe I'll go down to 3. Again, it doesn't always have to be the same. So let me see what that would be. So if I said y equals -2, and now I have a 3 plus 4. So -2 times 3 is, oh, that's going to be my same point. Of course, that's going to be my same point. So I should actually chose something bigger, because that's going to be a -2 times 3 is -6 plus 4. Y equals -2. So if I was at if I'm at 3, so I'm over here, I have to go down -2. And remember, these are all counting as 2. So this is my -2, -4. So that point is going to be at 3, -2, about there. Okay, so you see what I'm saying is you get to determine sometimes your own table of values. It doesn't matter, because sometimes I just want this line to look a little bit like, sometimes more points is easier, right? So I'm going to make mine in blue. And there we go. So there are my 2 equations, and I'm going to give it its name, because that's how you're going to get your points. This is y equals -2x plus 4. Voila. So I've solved it graphically. I've added a quick table of values. I could have said only solve it by a table of values, right? You have to be able to interconnect all of these different formulas, and I hope that helped.